So let's look at alcohols. Let's look at alcohols. Now, what is the functional group of alcohol? Now, this is the functional group. We have the general formula, right? Now, the functional group of alcohol is the OH functional group. And of course, the general formula for this guy is Cn H2n plus 1 OH, where this guy is an alkene group. So this guy can be written as ROH. Now, this R stands here is an alkyl group, and the general formula for alkyl groups are Cn H2n plus 1. Okay. Now, just like we did yesterday, the reason why I chose these three compounds to start with is because apart from the fact that they can ask us to name them, or they give us a name and request that we provide the structure, these guys have classifications, right? You can classify them into primary, secondary, or tertiary as the case may be. So first thing first, what is making this guy an alcohol, the functional group, right? What is making amide, like we did yesterday? Amide is CONH2. Amide is NH2. Alkanes, double bond, alkynes, triple bond. Alkanes are the only compounds that do not have functional groups, right? They are just known to have no functional groups at all. That's why their reactions, they don't really undergo so many reactions like that, because they don't really have what is reacting inside of them. Alright? Alright, so the general formula for this guy is this, meaning that if n is equals to 1, like if I have one carbon atom, an alcohol that has one carbon atom, most likely, if I put it to be 1, I'm not going to write the 1. 2 times 1 is 2, plus 1 is 3. We have OH. Now this guy is named as ethanol. Right? We're going to be looking at this shortly, how to name this compound. Now, if the N increases to 2, it becomes C2 here. 2 times 3 is 4, plus 1 is 5. Now, OH, this is ethanol. Now, this guy can be written, this is called like a condensed formula, or the molecular formula of alcohol. I can rewrite this guy as CH3, CH2, OH. Right? So, having said that, let's look at the various classifications of alcohols before we start their nomenclature proper. Alright. Please put down. Alcohols are classified into the following. Alcohols are classified into the following. Number 1, we have the primary alcohol, and of course, degree 1. The second, we have the secondary alcohol, that's degree 2, and we have the tertiary alcohols, that is degree 3. So these are the 3 classes of alcohols that we have, just like we saw in the case of amides and amines. We're going to take them one after the other. What actually makes a compound an alcohol a primary, and what makes it a secondary? So let me give us an example before I proceed to defining these guys. If I have something like this, CH3, CH2, OH. Now, if you want to check out the classifications of alcohols, first, identify the carbon bearing or the carbon that is directly attached, the carbon that is carrying the OH. First, let's identify that guy. I put an asterisk here. Now, this carbon here, if this guy is further in turn attached to one other carbon atom, like as you can see here, this is a primary alcohol. Now, If this guy be attached to two other carbon atoms, like in this case, that's a secondary alcohol. So if you actually want to identify whether an alcohol is primary, secondary, or tertiary, first thing first, identify the carbon that is actually carrying the OH. Okay, fix this guy, and then check out how many carbons are directly making contact with this guy. So this is one carbon atom, this is primary. Two carbon atoms, this. You might also want to use the hydrogen definition set. You could say that the case where the carbon bearing the OH is having two hydrogens, right? Yes, they actually gave us definition based on carbon and based on hydrogen. So let's place it down. Let's put down primary alcohol. Primary alcohol. Primary alcohol. It's a type of alcohol in which the carbon carrying the OH group, a type of alcohol in which the carbon carrying the OH group is directly attached to one other carbon. Is directly attached to one other carbon. The carbon bearing the OH group is directly attached to one other carbon. To one other carbon. Now, an example, we have CH3, this. I'm actually trying to be so polite or to be very lenient to write it down this way. The exam, they may not really show this. You can just see this written in this format, CH2OH, like this. Right? Now, so the carbon bearing the OH group is the one with the asterisk. The asterisk, this guy, is the one carrying the OH. How many carbon atoms is directly making contact with this guy? Just one. Which is this. So this is a primary alcohol. But we also have something like this. It's also primary alcohol. Now, sometimes I actually for me now, if I actually, write an exam and I see questions on that alcohols, I don't really bother myself checking through the carbons. I just check the hydrogen. If this carbon bearing the OH is having 2H, that's primary. Right? Because I might want to start, maybe they can give me the condensed form. They can give me something like this. And this is already confusing. Some persons will already see this as a confusing stuff. I don't have to start opening this guy. Right? First, this is a carbon carrying the OH. Also, how many H's attached to this guy? So it's primary alcohol. So is there any need for me to define this guy in terms of hydrogen for us? There's no need, alright? So just, is there any need? Alright, thank you. Secondary alcohol. Please put down. The type of alcohol in which the carbon bearing the OH group is directly attached to two other carbons. Type of alcohols in which the carbon bearing the OH group is directly attached to two other carbons. Carbon bearing the OH group is directly attached to two other carbons. Now we have an example. We have CH3, CH2, CH, CH3. This is the first example here. We also have another example. We have CH3, now, no matter how they want to take out this, just come here, put your asterisk here. This is the carbon bearing the OH group. Now, how many carbons are directly attached to this guy? This and this. I'm not interested on the other carbons here, except I'm asked for the name. So this guy, this and this. So it's very obvious how this is a secondary alcohol. Now let's look at the third one, tertiary, and after which look at some properties of alcohols. So we'll look at something else. Alright. Tertiary alcohols. Tertiary alcohols. This is a type of alcohols. It's a type of alcohols in which the carbon bearing the OH group is directly attached to 3 other carbons. Type of alcohols in which the carbon bearing the OH group is directly attached to 3 other carbons. The carbon bearing the OH group is directly attached to 3 other carbon atoms. So we have something like this: CH3, C, OH, CH3. Now this is an example. And we also have I don't really care how they want to treat the compound, as long as now the carbon at the center is a carbon bearing the OH group. So this is the first, this is the second, and this is the third. Right? So by the time you want to check out whether it is primary or secondary, just identify the carbon bearing the OH group. If they write it in such a way that they are all condensed, this stuff I can condense this guy. I can remember the last and stuff. I want to condense this guy. CH2 is in 3 places. 1, 2, 3. I'll come here and say CH3. I'll put in bracket and put 3. This 3 guy is attached to this carbon. I'll come here and put C. And this C is carrying OH. So this is this. Now imagine in exams they give us something like this. For me, I've already known that this guy is a tertiary alcohol even without splitting this. How? There is this guy is not having any hydrogen. If the carbon bearing the OH is not having any hydrogen, it means it's a tertiary alcohol. If it's having 1 hydrogen, it's a secondary. 2 hydrogen is what? Primary. Right? But I just want to stick to classification using carbon atoms. Alright, so that is that for. So if you look at this guy, if you now expand this compound, that's now when you'll be able to tell, even though so many of us here can equally get the correct answer from here. You can just say, but most of the times in exam setting, please make sure you expand it. You should never, take note of this, you should never do shortcuts. Let me just write it out. No, it's exams. Write it in full so that I can see it. Alright. So let's look at some physical properties of alcohols. Some physical properties of alcohol. Let's look at some physical properties of alcohol. Now, I want to discuss boiling points, and solubility. These are the 2 major ones that we always come across, right? Boiling points and solubility. Please put down. The first property I'd like to take up. Please put down. Alcohols have higher boiling points than their corresponding ether and alkanes. Alcohols have higher boiling points than their corresponding ether or alkanes. This is due to the ability to form hydrogen bond. This is due to the ability to form hydrogen bond. This is due to the ability to form hydrogen bond. Please take note of this. When I said alcohols have higher boiling points, it's actually relative to ether and alkanes. And I use the word corresponding. What do I mean? If I bring alcohol with 2 carbon atoms, I need to also bring ether with 2 carbon atoms, right? I need to also bring alkanes with 2 carbon atoms. I cannot bring alcohol of 4 carbon atoms and compare it with another compound of 2 carbon atoms. No, don't do that. You compare alcohol 2 carbons to ether 2 carbons to other guy 2 carbons. And now, if you notice, the reason why water has high boiling point is because water have ability to form hydrogen bond. Now, this is what I mean. Hydrogen bond is a bond between hydrogen and a highly electronegative element. I repeat, hydrogen bonding is a bond between hydrogen and a highly electronegative element. It's not a bond per se, it's an intermolecular force, right? A van der Waals force. So when I say hydrogen bond, if you look through your chemical bonding, right, you will not see type of bonding hydrogen bond. No. Hydrogen bonding is an intermolecular force of attraction. So let's take out the elements that bonds with hydrogens to form hydrogen bonding. Fluorine is highly electronegative, so fluorine will bond to H to form hydrogen bond. That's why HF is a very weak acid, because this guy would hold this guy so well, not willing to let hydrogen go. The bond is very strong. Now, fluorine, oxygen, nitrogen. Right? These are the 4 basic elements that anytime they combine with hydrogen, that is hydrogen bonding. So you don't come and expect this is not hydrogen bonding. Some persons can say, oh, but there is hydrogen here and there is a bond. No. So hydrogen bonding in water, this is how it looks like. This is how water looks like. Right? We have. So that is why you have water molecule coming together to form a large quantity. When you heat it, when you boil water, the heat breaks this bond and the water starts evaporating. Without breaking the bond, water will never evaporate. You now start seeing water as droplets. So these are, we have another guy here. We have the drawing is somehow. So we have O. That's how it looks like. So alcohol, for the fact that alcohol has OH, alcohol has hydrogen bonding already, right? So it can hydrogen bond with itself and other alcohol molecules. So now look at this. We now come here and say ROH, right? I have HOR. This is the first hydrogen bond. You have HOR. The second, we have OHR. So the reason why alcohols have a higher boiling point than their corresponding ether and alkanes is simply because they can actually exhibit hydrogen bonding with themselves. Alright, so note that point. So in case you see the exam, why is it that alcohols have higher boiling point than ether? Ether is like this. Ether also exhibits hydrogen bonding, but not with another ether. Ether can only exhibit hydrogen bonding when you mix it with water, because there is no hydrogen here. But if you have water, water has H, so the H of the water bonds with the O of this guy, unlike alcohol that has H and O, such that they can actually, form hydrogen bonding between themselves. So let's look at the next physical properties of alcohol, which is solubility. Solubility. Now let me ask us this. There's nothing to ask. Let's just say it at once. Alcohols are soluble in water, true or false? Are they soluble in water? Is it all alcohols that are soluble in water? How do they vary in water? Please, alcohols are soluble in water, but as the chain increases, right? The solubility does what? Decreases. Because if the chain increases, the chain is made up of carbon and hydrogen. And those guys are non-polar in water. They are non-polar substance. So the OH will not be able to cancel out the effect of that chain. Just like you have a good side and you have a bad side, right? If your bad side is too much, are you a bad person or a good person? Anybody that is always emphasizing. So please put down. Alcohols of 4 carbons and less are soluble in water. Alcohols of 4 carbons and less are soluble in water. Full stop. Alcohols of 4 carbon and less are soluble in water. Full stop. Their solubility decreases as the length of their carbon chain increases. Their solubility decreases as the length of their carbon chain increases. So you might see something like this. Let me take that again. I said alcohols of 4 carbon and less are soluble in water. However, their solubility decreases as the length of the carbon chain increases. That means if I have octanol, I have ethanol, and I have ethanol. Now this guy has 8 carbon, this guy has 1, and this guy has 2. Which of these will be the most soluble amongst all of them? Methanol, right? But this guy has 1 carbon atom. Which of them will be the least soluble? But in exams, they may not ask you like that. They can say, arrange the following in increasing order of their solubility. Right? That means you're starting from the least soluble to the more what? Soluble. So take note of that. So these 2 properties will stick to our head. So having said that, we are done with alcohols. Let's look at